Most people hear the words nuclear ship and think about submarines silently slipping through the ocean, or massive aircraft carriers with fighter jets. But what if I told you that the next generation of nuclear powered ships will be built for commerce, trade, not war? They'll carry cargo, power ports, and transform the global shipping industry. Welcome to The Afterpop. I'm your host, Danielle, and today we're going to be diving into the world of commercial nuclear shipping. Following up from our episode from Core Power, we're going to be following up with some of the differences between commercial and military nuclear propulsion, emergency planning zones and port safety, as well as regulations and oversight. So, let's start with the obvious question. What's the difference between military and commercial nuclear ships? When we talk about ships being powered by nuclear reactors, that's not a new concept. So why is it such a big deal to have nuclear ships commercially? Military ships like those in the U.S. Navy run on powerful, compact, pressurized water reactors. These reactors are designed for performance, speed, and stealth, not for cost efficiency or commercial viability. They're maintained by highly trained crews and are exempt from most international nuclear regulations. Now, compare that with commercial nuclear shipping. A company like Core Power is looking to develop advanced reactors that are simpler, safer, and more autonomous. Instead of requiring dozens of nuclear-trained sailors, these systems are being designed with passive safety features and remote monitoring. We're talking about reactors like the molten salt or lead-cooled fast reactors that are walk-away safe, meaning they can shut themselves down without human intervention. And here's the kicker. Commercial ships have to play by a completely different rulebook. They're subject to oversight by both the International Atomic Energy Agency and the International Maritime Organization. These ships won't just need naval clearance, they'll need to meet international nuclear safeguards, port safety protocols, and non-proliferation standards. According to the World Nuclear Organization, over 160 ships have been powered by nuclear reactors, mostly submarines and naval vessels. But the handful of civilian nuclear-powered ships, like the Soviet-era NS Sevmerput or the German-built Otto Hahn, were primarily test beds. Core Power is looking to take these lessons and build an entire industry for commercial vessels. Let's pause and get a little more specific. There's a difference between nuclear propulsion and nuclear electric propulsion. In direct nuclear propulsion, the reactor's thermal energy is used to drive turbines connected to a propeller. In nuclear electric propulsion, the reactor produces heat that drives a turbine to generate electricity. That electricity powers electrical motors that then turn the ship's propellers. Core Power is focused on nuclear electric propulsion. This setup gives ships more flexibility, efficiency, and allows integration with onboard energy systems, like refrigerated cargo or even supplying power at port. It also pairs well with modular advanced reactors that are optimized for high-temperature, high-efficiency electric production. In our last episode, we talked briefly about emergency planning zones and port safety. So let's get into it. One of the biggest concerns when you mention nuclear anything is what happens in an emergency. Traditional large-scale nuclear power plants require extensive emergency planning zones, or EPZs. Think 10 to 50 miles of evacuation plans, sirens, drills. That doesn't exactly work in a major global port like Rotterdam or Singapore. The advanced reactors Core Power is backing are safer by design. Because molten salt reactors operate at atmospheric pressure, they can safely drain into a passive cooling tank, and the risk of meltdown is drastically lower. That means that EPZs for maritime reactors can be significantly smaller. We're talking hundreds of meters instead of miles. This reduction in risk opens door for nuclear-powered ships to dock in ports, provide grid power, or even function as a floating energy hub during emergency or peak demand. Core Power has noted that commercial maritime nuclear systems will need to integrate seamlessly into port infrastructure, with full collaboration from local authorities. This includes radiation monitoring, port-specific emergency procedures, and transparent operations to build public trust. Now, regulations and oversight. Let's talk about the regulatory chessboard. The IAEA, headquartered in Vienna, oversees nuclear safety and non-proliferation. Any commercial nuclear reactor, even one on a ship, has to meet IAEA standards for fuel security, operational transparency, and environmental safety. Then there's the IMO, based in London, which governs international shipping. They create the safety standards, routing guidelines, and emission protocols for all ships that sail across borders. For Core Power, navigating these overlapping agencies means building a system that satisfies both sets of regulations. That includes everything from contaminant vessel design to automated safety diagnostics to how the ship reports its reactor status while at sea. This isn't easy, but it's one of the only ways commercial nuclear propulsion can scale. How does this actually get started? Like Toby Menzies said, it won't be a global rollout, at least not at first. What you'll likely see are dedicated trade routes, shipping lanes between ports and countries that are open to nuclear-powered vessels. Think Norway to Rotterdam or Singapore to Busan. These will act as proving grounds. Ports along these routes will be equipped with radiation monitoring, emergency protocol, and train response crews. The ships themselves will be tested extensively before they can even carry cargo. And once these early routes are running smoothly, the global network will probably follow. Why does this matter? Well, here's why. Shipping is responsible for nearly 3% of global carbon emissions, and yet it's the backbone of international trade. If we can decarbonize ocean freight using safe, scalable nuclear technology, we don't just clean up the shipping industry, we unlock zero-emission ports, floating energy grids, and a future where a single ship might not need to refuel for decades. That's what Core Power is aiming for. Thanks again for listening to The Afterbop, a quick breakdown of commercial nuclear shipping. If you liked this episode, leave a review, share it with a curious friend, and head over to nakednuclear.com for more deep dives on the future of energy. Stay curious.